Which astronomy stories get picked up by the media, which astronomy stories cause a story? It's always a little hard to tell. Usually if you've got a nice looking picture, and you know, you've got a nice picture of a galaxy here, they're the ones that kind of stir up the attention. So I think it's probably more to do with the fact that there's a nice picture than it's actually because it's overturning the whole of everything we know about galaxy evolution.
Well, it's not that nice a picture.
Oh, I think it's a nice picture. Maybe I'm just biased. I like spiral galaxies. So this is a new paper that's just come out on a galaxy called BX442. And what's remarkable about this, so here's the picture of the galaxy, which looks pretty uninspiring. Of course, the reason why it looks pretty uninspiring is that it's a huge distance away. It's about 10 billion light years away or thereabouts. And of course, why that's interesting astrophysically is that that means that you're looking at it as it was 10 billion years ago, because the light that's getting to us now was emitted 10 billion years ago. When we look at galaxies in the very distant universe, they look rather different typically from the galaxies we see around today. They tend to be smaller, which I guess sort of makes sense because galaxies have been growing over time, but also messier looking. They don't tend to have the beautiful structures we see when we look at nearby galaxies, the beautiful spiral patterns and so on. And so what's unique about this galaxy is it is a grand design spiral structure. It actually has a pretty clear spiral structure to it. So the reason why you don't expect to see grand design spiral galaxies there is because grand design spirals really require there to be a nice, well-behaved, cold disk of gas, which is turning into stars and forming spiral structure and so on. And when we study the very distant universe, it's a very much more turbulent pace, that gas hasn't really settled down into these nice, uniformly rotating cold disks of gas. And so no one was really expecting to find a grand design spiral galaxy that early in the lifetime of the universe, or that far away. And so that's why it was a bit of a surprise. Now what these guys have done is they've gone back and actually studied not just the stars in this thing, but the gas as well. And they found that actually, indeed, the gas is not a cold disk. It's not a nice cold disk that we thought should turn into a grand design spiral. And so that leads you to a little bit of a problem, because I just said that to have a grand design spiral you need a cold disk, and now they've studied the gas disk of this thing and it's not cold. But there is a little bit of a get out, which is that there are other ways, at least transiently, you can make beautiful grand design spirals. One of them is if your galaxy has a companion either whizzing past or in the process of merging with it, the effect of that as it flies past or as it merges can stir the galaxy up in such a way to, at least for a relatively short period of time, which is in astronomical terms like 100 million years or so, so short compared to the age of the universe, you can create these grand design spirals. And indeed, if you look at this thing very closely, you can see it does actually seem to have a little friend just over here, which might be enough to create this spiral structure that you can see in the galaxy. And so the likely explanation is this is a grand design spiral, but it's one of these ones that's been created by this rather unusual mechanism of a transient phenomenon of something flying past stirring up the grand design spiral. And so that makes everyone a lot happier, because actually it explains why they found it, but it also explains why it's so rare, because something which only happens for such a short period of time compared to the age of the universe means you're very unlikely to catch a galaxy in that particular phase. So the fact that they've only found one of these things now makes a lot more sense, because actually it's a rather unusual phenomenon that's causing it. It's been around, it's been known for a long time that interactions can cause spiral structure. And in fact, even in the local universe, if you look at some of the most beautiful examples like Messier 51, like the Whirlpool galaxy, it has this little companion. And it's clear when you look at the spiral structure that actually it's somehow being at least augmented, if not created entirely, by the existence of that companion. So that's been known about. It's not, we're not really just thrashing around desperately to come up with some explanation. It is something that's been known about as an alternative all along.
So this isn't like you found a skeleton of a human in the dinosaur fossil record?
It's not quite that bad. And always, the thing with astronomy is weird things happen sometimes. And when you find one weird thing, well, it's kind of interesting, but you don't throw away the entire theory, because there's always enough possible strange things that could have happened in that one particular case. It's when you then go and repeat the experiment and say, okay, so we found this one, let's go out and see how many more there are. If they actually found that there were thousands and thousands of these things, then it would start to become more of a problem. But for the moment, it's just an intriguing little case.
They're making a lot of conclusions from that smudge. Where is all the data in that smudge? How can they get so much information?
But you've got to bear in mind, they've got a lot more than just that smudge, right? They've actually taken images in lots of different wave bands, which means that they know what the colours of the galaxy are, so you can tell what kind of stars it's made of. They've actually taken spectra of it, so they can measure the spectrum of the thing, which tells you where the gas is in it, and actually by measuring the Doppler shift in various emission lines from the gas, you can even tell that this thing's rotating in a fairly uniform way. And actually from the turbulent motions of that gas, from how those lines get broadened, they can tell you how hot the gas is. So there's lots of data that's gone into this paper. It's not just one little picture.